I am Conrad Leyva, Director of Ecosystem and Workforce Education at CESMII, and I'm going to talk to you about making the most of this great moment and great opportunity ahead for growth in the manufacturing sector. I will discuss the need for smart manufacturing skills in today's workforce, why we need it, and what type of education is needed, and how CESMII's ecosystem of partners is tackling this opportunity and bringing the required education to bear. I hope that you will be motivated by our progress and decide to join our efforts because we still have a lot of opportunity in front of us. The U.S. is in a prime position to regain leadership in manufacturing. Reshoring is happening for several reasons. First, perhaps because it was never a good idea, but COVID definitely showed us that we need our suppliers closer. And the biggest reason might be because the products we make, the processes, and the machines we are using keep getting more complex. And part of the infrastructure needed for manufacturers is a workforce, a skilled workforce. And we have the best here in the U.S. For several decades, we didn't invest in manufacturing, and many jobs lost during that period. For many communities, there is a direct relationship between empty storefronts and lost manufacturing jobs. However, we're looking forward to an opportunity for millions of manufacturing jobs that will impact many communities. But we may miss out on this opportunity if we can't address two major challenges. When manufacturers are asked about their challenges to achieving the fourth industrial revolution, are they pointing at technology? No, at least not directly. Technology innovation is actually moving at a very fast pace, and it has become more affordable and practical to implement technology like sensors, connectivity, big data, and machine learning in the last 20 years. We can see how fast the price and capacity is improving with these examples from IDC and McKinsey. In fact, when we ask manufacturers, technology is not the biggest challenges. The two challenges are lack of talent with the skills required and lack of interoperable systems because integration is too difficult and too costly. These two challenges are holding us back from taking advantage of all the technology available today. At CESMII, we have set out to tackle these challenges through four strategic pillars. And at this summit this year, we have several sessions dedicated to talking about the enabling technologies, platform, and methods. A main theme through those sessions on the technology and platform is how to make systems more interoperable, because creating the required connection of data in the data-driven factory can get complicated. The CESMII Innovation Platform not only serves as a way to demonstrate technology, it also serves as a platform to help us teach the best practices, to thread solutions together for manufacturing. And we're not doing this alone. We have a great ecosystem of collaborators. An ecosystem with leading manufacturers working in R&D, sharing their lessons learned. An ecosystem with great technology partners, universities and colleges, working on education and training. I don't have everyone listed here, but this list gives you a pretty good idea of the great collaborators in this ecosystem. I know we stress in many presentations that all the practices are leading to higher productivity for industry. And that is definitely something very important to every manufacturer listening today. But I think it is important to highlight that higher productivity also leads to increased global competitiveness, which is key to our national efforts to keep encouraging and reshoring of the critical manufacturing supply chain. I think it is important to remember why we feel so passionate about these topics before we drill down into the specific of education. In this presentation, I want to focus on the biggest challenge identified by manufacturers, and that is the need for skilled talent. We will look closer at CESMII's educational strategic pillar and discuss what is needed for smart manufacturing education and how CESMII is tackling this challenge. The good news is that the data shows that the manufacturing sector is growing, and the growth is reflected in the demand for talent in manufacturing. Looking at the jobs posting data for the last few years, we see that the numbers show a positive trend and the demand for manufacturing jobs is increasing. Yes, we had a little dip due to COVID last year, but manufacturing was actually one of the first sectors that saw employment rebounding last year, a trend that continues today. Manufacturing jobs have been bouncing back with a projected growth of 17%. These are good paying jobs with a median salary of $46,000, jobs that have a significant impact on GDP for the country. Now, when we read of the outlook for the future of work, we can find many predictions about how automation is displacing millions of jobs in the next decade. But we can also find predictions of how many jobs are being created by automation. And in this case, the two predictions on how many millions of jobs are being lost and created come from the same World Economic Forum report. So which one is right? The answer is both are correct. And the bottom line is that millions of workers will need to be retrained. And they have to get used to a new reality where we need to acquire new skills every 2 or 4 years, thanks to the increasing pace of technology innovation. For example, look at the skills that manufacturers are looking for. This is a report of top occupations in demand by manufacturers based on their job postings. This comes from a Labor Insights database. You've heard from executives like the CEO of Microsoft saying every company is a software company. And this report shows how this is definitely true for manufacturers. This is an example from a few weeks ago. A friend from Raytheon wrote this post on LinkedIn looking for software engineers for his advanced manufacturing team. These are examples of the need for more digital skills in manufacturing. But many manufacturers don't just need software engineers. In many cases, it is better to add more digital and analytical skills to engineers and technicians. One of the first projects that CESMII worked on from the education side was identifying the smart manufacturing skills required by multiple occupations in manufacturing. And we're finding that the changing job descriptions for jobs like manufacturing engineer, systems architect, production technicians are matching the findings of those surveys that we did last year. This is a summary of the smart manufacturing skills requirements we have been refining over the last year, working with our ecosystem of educators that are focused on smart manufacturing education and training. These skills include the latest on IoT sensors and edge computing for data capture, advances in human-machine interaction, analytics, process modeling and optimization, and data-driven complex problem solving. And many of these skills for the multiple roles involved in implementing and leveraging smart manufacturing techniques. For an example of what this means in the job market, I looked closer at manufacturing and process engineering jobs. These jobs pay well and have a projected increase in demand. Looking deeper at the job posting data, we can verify that the demand for smart manufacturing skills is going up. Looking closer at a typical smart manufacturing skill for this occupation, like Python, you can see that, discounting last year, the demand for the last few years is increasing a lot for this skill in this occupation. And we are seeing similar trends in the last 5 years for other smart manufacturing skills. When we look at salary ranges for job postings with requirements for smart manufacturing skills, we see that employers are willing to pay more for these skills. I found that foundational smart manufacturing skills carry a premium of around $10,000, and that jobs requiring even more advanced smart manufacturing skills carry an additional $10,000 premium. This is great news for the workforce. I mean, there is some work to do in obtaining these skills, but once you get them, it means you can earn more money. So we know what is needed, and we are working with a great group of collaborators to make it happen. Let's drill down on how CESMII is tackling education. This slide summarizes CESMII's general strategy to generate and deliver smart manufacturing education at scale. We depend on our ecosystem to both develop education and deliver education. There might be a few offerings of education directly from CESMII, but by far the biggest impact on the workforce comes from our ecosystem partners. Like we said in the prior slide, we are developing and publishing resources built by the ecosystem for the ecosystem. And the repository of educational resources is at the center of that strategy. However, a little more to the right, the Smart Manufacturing Education Catalog of programs offered by our ecosystem partners is what really allows us to make an impact on national scale. Let's drill down a little into these. First, we made available to members of the ecosystem the Knowledge Portal. Over 300 members have been onboarded to the CESMII Knowledge Portal. This is not only a place to share educational content, but also a place to share about our technology, our network activities, including activities at innovation centers and affinity groups. The educational catalog, it's online and always up to date. It includes articles, papers, and videos. And it's easy to find what you need through a great text search feature that searches resources all across the site. One of the first resources we published was an updated smart manufacturing definition and set of guiding principles, because we do not want the vision of smart manufacturing watered down by misconceptions or relabeling of Industry 3 practices. We need a good foundation for education on smart manufacturing. And our ecosystem and education partners are all on board with this mission. By the way, I am training on the smart manufacturing principles November 10th. So don't forget to attend that session. Another resource example is our recorded conversations and sessions with smart manufacturing experts. Experts that are sharing their experience and insights on smart manufacturing from the many different perspectives of business leaders, engineers, solution implementers, and educators. We continue to expand the educational resources in the Knowledge Portal, including more on the first principles and best practices for threading together smart manufacturing systems, including the use of smart manufacturing profiles and the Smart Manufacturing Innovation Platform. Make sure to subscribe to your favorite pages on the portal to get notified when we post new content. A new resource that we are previewing at the conference and releasing this year is a set of business transformational tools to help manufacturers accelerate their innovation efforts. The tools are targeted to help small, medium-sized manufacturers, but they work for manufacturers of any size. They will be as much self-serve and do-it-yourself as possible to keep costs down. However, CESMII is developing a network of consultants and service providers equipped with these tools, and a network willing to help with small, medium manufacturers at a practical, low cost. The tools include Smart Manufacturing Business Process Assessment, Roadmap Building and Justification tools. Manufacturers can start this process with a self-assessment either on their own or assisted through an interactive workshop. We started doing some of these workshops, and we're doing one also November 10th. So please check out that session and invite your manufacturer friends to that one. The acceleration frameworks moves you through these processes here in the diagram, from assessment to exploration to building a roadmap. The roadmap is custom for each manufacturer, but the tools provide templates, building blocks, and examples to help the discussion along the way, and make sure that the manufacturer is exploring practical options for them based on their needs and goals. Each assessment step establishes a starting point for that organization. You might be surprised about the range of perspectives when you do this exercise as a group in a company. The explore step is about converging on a desired future state for the organization with an understanding about how technology can enable new business processes and models that leverage data and connectivity. It is very important to create consensus in the team about the current and future state. And the roadmap should establish practical milestones along the way. It is generally not practical for organizations to make huge leaps in one step and try to implement smart manufacturing in one huge step. Milestones are needed that allow us to achieve incremental benefits to the organization. The network of consultants will not only be using the tools that we're developing, they will be part of the ongoing evolution of these tools and bring their own industry focus and expertise to each engagement. I have my contact information at the end of the presentation, and if you're interested in this, please reach out to me. For the manufacturers that are developing their own education and the over 30 educational institutions participating in our ecosystem, we're providing resources and funding to help accelerate their efforts towards creating and enhancing their smart manufacturing education programs. The RFP project waves include education projects that are generating resources that are being leveraged into new smart manufacturing education programs. We're lucky to have a great collaboration among a great group of educators across the whole country, all interested in accelerating the inclusion of smart manufacturing techniques into their curriculum. The resources are made available to the ecosystem through the CESMII repository of resources for educators. This year, we launched 4 RFP2 education projects, and we're currently reviewing a great group of proposals for RFP3 with a focus on workforce upskilling and credentialing. The education kit from Penn State is a great example of the type of education program we're funding and the type of collaboration we're promoting in our ecosystem. We will hear next from Professor Joe Schufe from Penn State, talking about their program and experience working with CESMII.
Hello, everyone, and thanks for joining this session on education and workforce development. My name is Dr. Joe Schufe, and I'm the program coordinator for the Electromechanical Engineering Technology program here at Penn State, New Kensington. We actually completed our project, which was titled Factory 4.0 Education Toolkit, last year. It was a joint effort between Dr. Brian Anthony's team at MIT and our team here at Penn State. So the concept for this educationally focused project was actually developed back in 2018. And I really am happy to see since then, momentum has sort of gained in this space of smart manufacturing. And I've seen many programs now, academic and non-academic, being pushed forward, which I actually believe is in part furthered by CESMII's leadership in this area. So thank you, CESMII. However, there's still quite a gap in workforce readiness in smart manufacturing. Sort of the rapid pace of technology availability and development, especially in the digital range from an analysis to modeling, is only making that more difficult to address with students and current workforce members. So our goal, as it stood and still our goal, is to create an educational toolkit for CESMII members consisting of hardware, software, and educational modules that can be used or adapted by the members for CESMII. So I think we quickly realized early on in the project that the educational materials would need to primarily focus on the data and the data-driven approach to improving manufacturing processes. So the hardware, which is based off of Dr. Anthony's fiber extrusion tool that they also use in the MIT Smart Manufacturing Education, it becomes a data generator and a mock process for improvement. However, the core is the data system around it. So our core approach in developing sort of this toolkit was to build a sort of modern IIoT, or Industrial Internet of Things, data network and processing environment to be able to explore the use of data and simulations in a manufacturing environment. That focus on the sort of data and software makes it a bit more hardware agnostic for translating the materials to other programs, depending on equipment that you have. So the concepts are all there. We use this piece of equipment as sort of a foil, and it works really well for that. And it's one that is relatively inexpensive to set up on their own. So if you look to the right here, for the toolkit, we focused on setting up this data network, sort of a SCADA, if you will, but it uses an open source materials more appropriate for an educational environment. to create basically an MQTT and OPC-UA communications platform. So we centered around those two protocols with data storage and connection to the CESMII Smart Manufacturing Innovation Platform. With that network set and built and provided as part of the kit, you then can aggregate data from the extrusion system. You can also, as we demonstrate in the kit, is explore adding on IoT sensors to the tool. We did power monitoring sensors in this case to add an energy monitoring capability, which is a common equipment retrofit. So once you have that data into the network and available to the participants, we can then have everyone connected in that network view the data, create dashboards on their own PCs, pull the data for analysis activities. So basically everyone on that local network has access to that data. From there, then we can go as far as we want down this road of smart manufacturing. We start with statistical data analysis, data preparation, contextualization. Then we move on to modeling of the tool and various processes within it, both with analytical techniques and empirical, all the way through machine learning and giving engineers an introduction into that. Those models are then demonstrated as a self-running digital twin that can run alongside the extruder, pushing data into the data network, and then that allows a sort of culmination in the trainees looking at the simulated data and the actual data to optimize run conditions, make augmented control algorithms, and even smart monitoring, which we have specifically monitored the motor health. So again, the educational objective is very much focused around the data, from collection and aggregation to analytics and digital twin development. So that was our sort of architecture plan for the project. Now, what we were able to accomplish was basically delivering a lot of that. Well, essentially, we provided as many of these materials as we could. So for CESMII's educational repository, we provided the full set of educational learning modules, which include presentations, videos, video demonstrations, data for running the exercises, and some recommended activities. The hardware materials and the sort of build instructions for that extruder are also included, along with all the software to run it, to do all the analytics, to run the communications, all in a GitHub repository. The software kit includes two ways of controlling the extruder, just in case. We have a microcontroller-based control for a very inexpensive system, or I have a PLC control option, which is what I prefer for industrial training. Now, the educational modules, of which there are many covering all those various topics, they're not a recommended course plan. There are far more modules than I could fit into a 15-week college course, for example, and many of them are a bit too advanced for maybe undergraduate engineering students. But they're all just pieces that you can kind of put together for a program. So I have a set that I like to do with my students, which are more of maybe some fundamentals of instrumentation mixed in with some basics of data analytics, than I would with maybe industry folks who want to see more about OPC-UA and other communication schemes. These modules that we created, they were endorsed by CESMII as part of their catalog, which is great. Now, we have been delivering these materials for the past couple years now. And I have done 2 complete course sections with my students. They're seniors, and it's a smart manufacturing technical elective. And I'm converting that into a proper across Penn State course offering. I also assessed those as part of this project with some pre and post surveys to help improve it and provide a report to CESMII. During the project, we also ran a pilot training with some industry participants. That was in the summer of 2020. That went really well, and we translated that into a very formal industry training that we ran this past summer, which actually went fairly well. I was pretty happy with it. It was a lot of in-depth stuff. We did part online, and then we had people together for a week, a lot of coding, a lot of Python, but it went fairly well. That was part of our what we call digital foundry efforts here in New Kensington, where we're helping manufacturers modernize and digitalize their processes, and that will continue, and we're continuing that, offering that quite often. My goal for my spring course offering is to actually get some more activities with the Smart Manufacturing Innovation Platform. So I'm trying to work that together and get that set up so I have a good demonstration. Moving forward, we're standing this course up at a couple other Penn State campuses, specifically Berks campus for either the spring or fall. They're out near Philadelphia. I've also had a variety of other educators from various institutes join on some of my trainings, and I ran some train the trainer sessions with Conrad at one point. I personally would be happy to help any others that request it with the materials, how to get started with it. It's a lot to take in at once, and I will continue to be refining and evolving the materials as we go along. So please reach out to me if interested. I'll walk you through the materials, talk about what works and what hasn't, maybe update you with my latest stuff. So that's what I have. I'd like to thank CESMII for sponsoring the project, and thank you all again for joining this discussion. I look forward to continuing my work here with CESMII and this community in smart manufacturing education. So thank you.
Thanks, Joe. Your project is a great example. And we have more projects like Penn State in process right now. This slide, you can see the logos of the great partners we have working with us on these 4 education projects. Partners including Purdue, Festo, West Virginia University, University of Texas El Paso, and Auburn, along with their technology and industry collaborators. These 4 projects are slated to complete next year, each creating different types of resources and programs, all towards smart manufacturing. West Virginia is creating smart manufacturing modules to use across several engineering disciplines. Purdue is creating a new undergraduate program on smart manufacturing that challenges the traditional boundaries between engineering and computer science schools. And the University of Texas El Paso program is one of several of our projects helping this invested community and increasing diversity in the talent pool. One last category of resources are the apps, simulators, and labs that we are making available for hands-on education. Because many manufacturers want to hire employees with hands-on experience with industrial tools and software similar to what they find in their own operations. We're providing resources for educations like simulators and hardware kits that feed data, and resources like smart manufacturing apps that consume data for visualization and analysis. Both resources will be ready for instructors to incorporate into their own courses. Some resources leveraged by our ecosystem are big industrial machines that our partners at our regional Smart Manufacturing Innovation Centers have integrated into the Smart Manufacturing Innovation Platform, all the way with smart manufacturing apps to help us demonstrate the best practices for integration. This is an example of the industrial equipment available for education at our Smart Manufacturing Innovation Centers. These labs at NC State are used to demonstrate how smart manufacturing profiles and the Smart Manufacturing Innovation Platform can make it easier to connect the machines and sensors to the systems for intelligence and optimization. Other resources that we're producing are more affordable solutions for hands-on education at community colleges. We have a project starting this year to design and prototype a hardware kit that we can make available for under $5,000. That's our target. And projects to build simulators and digital twins that emulate the type of industrial assets that can be found at innovation centers, but can help us make that data and those types of data sets available to colleges that might not have the budget to maintain their own industrial assets. The Smart Manufacturing Education catalog of programs offered by our ecosystem partners is what really allows us to make an impact at national scale. The Penn State and MIT Smart Manufacturing program we discussed before are some of the current programs in the education catalog. These programs do not necessarily come out of RFP projects. We have a CESMII endorsed program to review and recommend enhancements to any education program geared to teaching smart manufacturing skills to different manufacturing occupations. We have currently a small but quality list of programs on the list, but we will continue to add programs and promote smart manufacturing skills at a national scale. If you're interested in this program, please reach out to me. And I'm excited to announce that we're partnering with SME and ToolingU to expand the portfolio of smart manufacturing education. Through this collaboration, we plan to accelerate and amplify the smart manufacturing vision and message, educate and drive innovation, addressing the skills gap with flexible solutions for manufacturers and their workforce, and expand the expert community by bringing together the CESMII ecosystem of subject matter experts and ToolingU committees, education infrastructure, and national footprint to help us document and share best practices for smart manufacturing. By partnering, we're looking to simplify, align, and avoid duplication, to bring clarity for industry and education. There is a strong and growing foundation of resources already developing, and through this collaboration, we want to continue to build on that base and expand as smart manufacturing continues to evolve. In this presentation, I discussed the great opportunity we have ahead for a thriving manufacturing future. And I shared several ways that CESMII is helping tackle some key challenges that are slowing down progress towards that future. We still have a lot of opportunity in front of us, and we will still continue growing this ecosystem. If you're interested in these efforts, join us. Our contact information is at the bottom of this page. I appreciate you listening to this presentation. I'm going to pause here and open up for questions shortly.